Hello and welcome back. This is presentation 7.3, point and interval estimates of the population mean. This material is in your workbook pages 7.1 through 7.3, in your textbook chapter 7. We're going to look at an illustrative problem where we're talking about the health of animals in the north, in particular newborn seal pups. A random sample of 36 newborn pups is selected. The sample mean is determined to be 88.42. and we assume that sigma is around 9 pounds. So let's look at what inferences we can make about the population. From the central limit theorem, we have under repeated samplings, the sample means will be approximately normally distributed, and the mean of the x bars will be almost the same as mu sub x. And the standard deviation is given by sigma square root of n, or 1.5, called the standard error. And then looking at your screen there, we can see that a 60% confidence interval determined by one of these sigma sub x bars, 60% turns out to be plus or minus 1.5. We can be 60% certain that x bar will fall between these two red lines. If we extend that to 90% range, 90% corresponds to a z-score of 1.645. Multiplying it out is 2.47, and that's what you see coming on the screen here. Now for 95%, it's 1.96 times 1.5, and for 99%, we have 2.575 times 1.5. Now we're looking at the notion of a confidence interval. So again, you see on the screen here, we have a standard deviation of your x bar is 1.5, 95% margin of error is 1.96 times that, or plus or minus 2.94. And as you can see here in the red over on the right, this is called our margin of error, and that's the notion that 95% of the time x bar will fall in this region. Now we're going to extend this downwards, and we're saying that 95% means that 19 out of 20 of these x bars, now these red dots denote x bars, will fall within that region of these two red lines, and I think we have 20 of them there. Now we start at the top and we take that those two bars there, plus or minus 2.94, and subtract them from the x bar, and look what we've got here. You can see that we've got intervals, and all these intervals contain that center line, or mu sub x, except this one here, and generally 19 out of 20 of those intervals will capture the true population mean. So if one were selected at random, there'd be a 95% chance that that interval will capture the true population mean. So if we have x bar to be 88.42, we have here 88.42 plus minus 2.94, and we get rise to this interval. And so we're saying we're 95% sure that this interval, which turns out to be, as you see on the screen there, 95% certain that that interval will capture the true population mean. Now we're going to look at some terminology that when we undertake analysis such as this, we have the standard error. This is the standard by which everything else is measured. The margin of error is given by your z times your standard error, as you can see on the screen here. And that margin of error is given here on the screen, and you can see it on the right here. 95%, 1.96 times 1.5. Now in this case, this should be 99%. Is 2.575 times your standard error, and we see those coming on the screen here. Now notice that the subscript corresponds to the z-score. This gives us a confidence interval, and we have the three confidence intervals for various levels of confidence on your left here. Now once again, pause the screen and have a look at the problem on the board. We have a sample of n equal 41 men, and their weights were recorded, and the sampling was found to be 172.4 pounds. Standard deviation 25.2 is known. What can we say about the population? And we have here on the screen the margin of error, 95%, 1.96 sigma over square root of n, or 7.71. And this means that on the right here we have that 95% of the x bars will fall between those two red lines, or plus or minus 7.71 of the population mean. our confidence interval becomes, if we have x bar to be 173.4 plus or minus 7.1, we have this interval, and that's it here. So again, we're 95% confident this interval will capture the true population mean. If you wish to find an estimate of mean weight to within 4 pounds, look what we got here. We have 99% confidence. We have the sigma, n is unknown, and this is your error, plus or minus 4. Solving here, cross multiplying, solving n is equal to 264. So this means that to go to this level of accuracy, we must shove up the sample size to 264. This means that this curve will be sufficiently narrowed to make that error that small. If it claims that the elevators were based on a mean weight of 160 pounds, what would you suggest happen? Change the signs and lower the number of people. And this is the end of presentation 7.3. Please review it once again, take notes, and proceed to lesson 104.